I've built two new circuits here. The one on the left still has a 9-volt battery, and now it has two resistors. And the resistors are in what we call series, meaning after the electrons go through one resistor, they then go through the other resistor. The circuit on the right is showing two resistors that are in parallel. And it sounds literal, like the two resistors are parallel to one another, and that can be the case, but that's not the required definition. It is that as the electrons leave through this circuit, or as the current flows, it can go this way or that way. I'm going to now show the current. I'm showing the positive current here rather than the electron flow. And you can see that in the circuit in parallel, when the current gets to here, some of it goes this way and some of it goes that way. Then it comes back together and joins back up and goes back through the battery. When we have them in series instead, after the electrons or the current goes through one resistor, it then goes through the next resistor. One thing that changes with these besides the current is we can look at the voltage. So here, when I have two resistors in series, and I measure the voltage of this one, it's 4.5 volts. And I measure the voltage of that one, it's 4.5 volts. If I change the resistance of one of these, I'm going to increase this resistor up to 20. Now you'll notice that the voltage drop across this resistor, or the change in voltage, or the change in driving force between here and here is now 6 volts. But if I were to look at the drop across this resistor, it would be 3 volts. Notice that the 3-volt drop and the 6-volt drop add up to the total of 9. Over here, however, if I were to measure the voltage drop across either one of these resistors, in both cases, I'm going to find that it's 9 volts. When I have resistors in parallel, each branch gets the same voltage. If I were to look at the current, let's see if I can put my voltmeter back. Okay, if I were to look at the current, so I'm measuring the amperage now, and I measured on this resistor 0.3 amps, on this resistor 0.3 amps. So two resistors in series get the same current. I'm going to change the resistance of one of these guys. Let's take them up to 21. Now, if I were to look at the current at this point leaving the battery, 1.35 amps. But if I measure the current through here, 0.9 amps. So of the 1.35 that came in, 0.9 went this way, meaning the remainder must have gone the other direction. And indeed, 0.9 plus 0.45 add up to 1.35. Over here, the current was the same everywhere. So the takeaways from this are when you have resistors in series, they get the same current. When you have resistors in parallel, they get the same voltage. Each one of these each branch has the same voltage. I have now modified my parallel circuit to have two resistors in series and in one of the branches. If we watch the current flow, some goes this way and some goes this way. Notice that the current is moving faster through the branch with less total resistance. That's an application of Ohm's law. And moving slower through here. If I look again at my ammeter, 0.45 amps and 0.9 amps, the same as if I had a 20 and a 10. Looking at my voltage, if I check at the voltage across this whole branch, it's 9.5 volts. But each resistor is only consuming a portion of that.